Right, so here we have an Iconica 3 kilowatt, I think it's a 3 kilowatt inverter, hybrid inverter. It's having a few issues and they're intermittent and we don't know what they are, and it's very difficult to try and figure out what is the matter with this or what part of the system is playing up if we don't have some sort of monitoring system. Now these cheaper inverters, they typically don't come with, or at least I thought they didn't come with sort of software and monitoring. However, it turns out they do. You can actually plug, if I'd just read the manual on this sooner or looked at some YouTube videos, you can use things like Solar Assistant or Home Assistant running on a PC or a Raspberry Pi to do some monitoring on this. However, I didn't know that until recently, and I'm glad I didn't know that actually, because I went down the route of using an Arduino. Now what is it that I wanted to do with this? Well, I wanted a system that was autonomous. Well, I say that, I'll backpedal a little bit. I'm glad that I didn't know about the onboard monitoring system on that inverter, because I quite like the idea of having an autonomous system to do some monitoring, because you're not sort of beholden to all of the stuff like all of the software glitches and things like that in the inverter, although I don't know about that yet, so I'm going to do that next. But I don't know how good the software is, I mean. But anyway, this is my Arduino project. Now what is it that I wanted to do? Well, I thought to myself, well, if I can measure the battery voltage, this is a 24 volt system, if I can measure the battery voltage and if I can find out how much current is flowing in and out of the battery at any given time, and I can monitor that and have that data, then I can try and start to understand the behaviour of this system. So let's have a look what we've got here. So this is my Arduino, and on the Arduino I have bought an SD card shield and a real-time clock shield, and this was a really valuable bit of kit. I'm going to put everything I've bought in the description, but this is currently monitoring the battery voltage via a voltage divider circuit. So there's my two resistors in series, and this is my incoming cable that's connected to the batteries, and it's actually connected, there it's connected via that, it's connected to these two terminals here. So that is measuring my 24 volts, and I'll explain more about what a voltage divider circuit does, but to be honest with you, there's so many videos out there, you can just go and look yourself, voltage divider circuit, you'll find it. The reason you need it is because the input to the Arduino, you can only have 5 volts input to the Arduino, and obviously this is 24 volts. We have to do some electronic magic, because there isn't much you learn just doing a very small project about electronics when you start to mess around with Arduinos. So that's the voltage input. Now we've got the current, and I bought this CT clamp here. So that measures the current going in and out of the battery. It's got an arrow on it, so it's measuring the, so in this case with the arrow pointing in this direction, and you'll see this in the data, anything that's going into the battery will be a negative number, and anything that's going out of the battery will be a positive number, which is fine, and you can swap that around if you want, that's no issue. Right, where are we? So that's going into this port here, which is going into an analog port via, but I'll explain all of this when we get to the bench. So we've got our real-time clock, which gives us our time and date for the data. We've got an SD card here plugged in, so all of the data will be saved to this SD card. And there's one other thing we've got here, and that is our power in. Now this sort of power jack here, I think it can take up to 20 volts. I can't remember now from the data sheet, but they say about 12 volts is good for this. Obviously it's drawing very little current. I had a 24 volt to 12 volt DC supply transformer there, 30 amps, just 24 volt to 12 volt. So I just decided to use it. It was hanging around the place. I thought I'd test it and give it a go. So there's 24 volts going in there from these two batteries in series, and then I'm using that for a 12-volt supply for my Arduino. Now, so that's the basic setup. I've got it in a plastic tub, waterproof, and this has been running for a couple of weeks now, and it's absolutely fine. It's been working great. And so in the next video I'll show you how I'm getting the data out of that, and also how to operate it as well, and some of the quirks that occur. And then in sort of the next videos going forward, I'll show you the code and talk you through how it all works. Alright. I'd like to show you at this point how this is going to work in practice. This has been recording data for a couple of days. It's always a moment when you take out the SD card. You can just unplug the SD card on these things. You don't have to stop them in any way. Plug this into my laptop, to my Mac. Now that should have created a folder. Right, so here's the file it's made. It's called DCEM, and I'll explain why. There's nothing. It's just what the file name is. Right, what have we got here then? We've got the date, we've got the time, we've got the voltage, there's 23.44 there. We've got current, 0.38. I don't remember what these are. We'll have a look later. I think one's the watts, and one's the watt hours, I think. So that's the data that we are getting out of this, and we can export that then into Excel or whatever you want to analyze it. Okay, so that's the data you get out of it. Now I'm going to copy this file, and maybe I'll drag it onto my desktop actually, and then I'm going to delete this. And then I'm going to start again. How big is that file? 1.4 megabytes. Oh, you know what? Maybe I won't delete it. No, I am going to delete it. Okay, we'll close that. So SD card, I'm going to put it back in. Now the way this works is, and I've had such a large amount of trouble with the iterations I've done with this. That's not going to do anything now. To press the reset button, and then it will reinitialize the program. And then we should start recording data. And it's recording data every 5 seconds. And it's getting its time and date from this real-time clock, which is integrated into the circuit somewhere. So that should have given us a couple of data points. Let's have a look. SD card is back in, 137 bytes. Let's see what data we have. There we go. There we go. So our battery's up to 25.12 volts, and we drag it in about half an amp from the solar. Okay, that's it. I'm going to put it back in and let it record for a few more days. Actually, something to note before I do that, I like to give as much information as possible, because this kind of thing matters when you're trying to do a project like this. I put the SD card back in, I'm going to press reset. Now that hasn't overwritten any data, that's just going to add to the data we've already collected, right? Which is important. These little things get annoying when the things don't work the way in which you want them to do in the code. So next we're going to have a look at this on the bench and have a look at the code.